Hello everyone, engineering statistics and linear algebra. In this video, a linear transformations concepts will be studied. We know that a matrix moves a subspaces around when we multiply by a matrix A. The null space goes into a zero vector, all vectors go into column space since AX is always a combinations of columns. So one interesting concept of a linear transformation is A takes its row space into its column space, and on those spaces of dimensions R it is 100% invertible. That is the real action of A. It is one of the important and beautiful property of a linear transformation. It is partly hidden by null space and left null spaces, which lie at right angles and go their own way towards zero. The next point is what matters now is what happens inside the space, which means inside n dimensional space, if A is n by n matrix, that demands a closer look here. Suppose X is an n dimensional vector. When A multiplies X, it transfers that vector into new vector AX. This happens at every point X of the n-dimensional space Rn. The whole space is transformed or mapped into itself by a matrix A. In the linear transformation, we do discuss the four important properties here. The first one is a multiple of an identity matrix. A equals to a constant multiplied with an identity matrix I. Stretches every vector by the same factor C. The whole space expands or contracts. So that we can observe here. It is an identity matrix multiplied by a value C. So as a result, the matrix either it can be stretched or it can be compressed. And also if the negative value of C is considered, even it can take its opposite direction. So this is the first property of a linear transformation. Consider any matrix A. It can be either stretched, compressed, and its direction can be changed to its opposite direction by multiplying an identity matrix with an constant C. Alright, the next property. A rotational matrix turns the whole space around the origin. So this example turns all the vectors through 90 degrees, transforming every point xy to minus y comma x. Consider here it is an matrix A 0 minus 1 1 0. It rotates the given matrix given vector into 90-degree rotated matrix. If this matrix is multiplied for any of the matrix, as a result 90-degree rotation can be observed here. Consider a graph here. Consider one matrix along x-axis. Its value is x comma y. If the matrix A with this value is multiplied this matrix, as a result we do find a 90-degree shift, 90-degree rotation in the given matrix x comma y. This is the a linear transformation property, that is the use of a rotational matrix to rotate the given matrix to a 90 degree. The third property, a reflection matrix. A reflection matrix transforms every matrix into its image on the opposite side of the mirror. In this, consider an example. The mirror is the 45-degree line, that is y is equals to x, and a point like 2 comma minus 2. is unchanged. The point like 2 comma minus 2 is reversed to minus 2 comma 2. So consider the next point here. On the combinations of the vectors like 2 comma 2 plus 2 comma minus 2, if these two vectors are added, what is the result? Y component is 0 here. X component is 2 plus 2, that is equals to a 4. The matrix leaves one part and reverses the other part. Consider the next possibility. The output is AV, that is 2 comma 2 plus minus 2 comma 2. In this case, the X component is 0. Y component is 4 here. That reflection matrix is also a permutation matrix here. It is algebraically so simple, sending x comma y to y comma x, that the geometric feature was coincident. It is a matrix. It performs the reflection of the given matrix, and this graph shows a reflection of a 45-degree mirror. So the next property, a projection matrix. A linear transformation fourth property is a projection matrix. A projection matrix takes the whole space onto a lower dimensional subspace. The example transfers each vector x comma y in the plane to the nearest point x comma 0 on the horizontal axis. That axis is column space of A. The y-axis that projects to 0 cross 0 is the null space. This matrix gives the a projection of um, any matrix, and you can observe the graph here. So consider a vector x comma y along the x-axis. For that matrix, if a matrix is multiplied, as a result we do get a projected matrix of a given matrix. So it is a linear transformation. There are four properties, that is stretching and compressing and even making the direction opposite. The second point is a rotational matrix. Third point is a reflection matrix and the projection matrix. So summary of this video is given in this table here. All right. So like, share, comment on the video, and don't forget to subscribe the channel. We see in the next video. Thank you.